Alright, so let's continue. Sorry for the late upload on this, for anyone who is needing it. I have not been feeling well, and I was hoping I'd be feeling better by today. I'm not, but feeling a little bit better than yesterday. So we're going to do 6 to the end of the homework for our spring break assignment. Let's see, x squared and then square root of x cubed minus 3 all over y squared. Alright, so again, we haven't been given an initial condition for this, and we got to separate our variables. And this one's not too bad. We get the integral of y squared dy is equal to the integral of x squared square root of x cubed minus 3 dx. And so left-hand side's pretty easy. I did 2 steps in one. So I multiplied both sides, like I cross-multiplied and then I integrated. So we get y cubed over 3. Now this side, we might have to do u substitution. On this side, if we said u was equal to, let's see how we can camera, yep. U is equal to x cubed minus 3, then our du is equal to 2x squared dx. Whoop, no, 3x squared dx. So we're pretty close there because we have x squared and we have dx. So I'll do the other method than I did in the previous problem. So I've got dx over here. I've got a 1 over 3x squared du. So if we do that substitution, then we're having the integral of x squared, square root of u, and then instead of dx, I can write my 1 over 3x squared du, right? So with that, the x squareds are going to cancel, and that 1/3 we can bring out front. So I can say this is 1/3 times the integral of u to the 1/2, or square root is just u to the 1/2 du. And that's a very easy integral for us to handle now. So we'll get 1/3 u to the 3/2 times 2/3 plus c. So y cubed over 3 is equal to that. And then so that's 2/9. And instead of u, I'm going to plug u back in and get our x cubed minus 3. So 3/2 plus c. And again, if we had an initial condition, then at this point, this would be the best place to go in and find that initial condition. But we don't. So instead, we're going to solve for y. So multiply both sides by 3. In doing so, there's a few ways we could write this. So I'm gonna leave it kind of messy first and then make it nicer. So we get y cubed, because I want to be the most helpful with my explanations here. So I can distribute this 3 to both of those. I got 6 over 9, or 2/3, times x cubed minus 3 to the 3/2 plus, and we could write 3c, and that's the part that's kind of wonky. We could just call that a different c and get away with it perfectly. So now to finish this, I'll take the cube root of both sides, and we'll get that y is equal to the cube root of 2/3 x cubed minus 3 to the 3/2 plus c2. There. It's a different c now. Whoa, okay. So I can say 3c, c2, whatever. I really want to make sure that in these videos I'm going through and doing the messy algebra and being careful with it, because that's something that the more I do on camera, the better. Okay. Anything worth talking about? Yes, okay. Cube root, when we cube rooted both sides, you might be angry that I didn't plus or minus, or you might be like, oh yeah, shoot, we were supposed to plus or minus. Well, no. What happens when we cube a positive? We get a positive. Positive times a positive times a positive. We get positive. What if we do negative times a negative times a negative? We get negative. So when we cube root both sides, or any odd root, we don't worry about plus or minus because there's no possibility for a negative to turn into a positive. So that's that. All right, where's my stack of work? All right, I want to save this for when I upload it in PDF form later. All right, number 7. Oh, go to a shorter one. dy dx is equal to secant squared x over tan y. Okay, so at first I was like, oh, I want to do some simplifying, but we have x in this one and y in this one, so no, we can't. So if we take the integral of tan y dy is equal to, excuse me, the integral of secant squared x dx. Okay. I'm having a hard time remembering the integral of tangent, so I'm going to have to do some stuff over on that one to figure it out. The right-hand side's easy. We take the derivative of tangent to get secant squared, and so this is going to be tangent x plus c. It's a nice and easy problem. But now if we're looking at the integral of tangent of y, I could think about this as sine y over cosine y dy and do a u substitution on that. And in general, I want to pay attention to the denominator of this. What lets me know that? Here, we'll just do a quick aside. When in doubt, try them both, see which one works. I know a lot of you guys are really good at that idea of like, okay, I got to try more than one thing. Let's say u is equal to sine y. Let's just kind of play that out and see what happens. So du is equal to cosine y dy. So everything shows up. Now, if I go and I substitute back in, I'll divide both sides by cosine y, and that's equal to dy. So dy is equal to du over cosine y. My goal with u substitution is a lot of cancellation. So right now when I do this, I get u over cosine y, and then instead of writing dy, I'm going to write du over cosine y. Guys, that doesn't cancel. Instead, I now have u du over cosine squared y. And maybe, okay, so I'm just going to try. I will do one of these when I finish this part, because I'm not going to timestamp it, if you don't care to see what happens here. So I'm just going to play with this and see what happens. So let's see, I need to figure out a way to get rid of the cosine y. Can I say the integral of u secant squared y du? But I still don't have... Never mind, I'm just stuck. Okay, so instead, let's go with the one that we can actually do. So if we were to try u is equal to cosine, then du is equal to negative sine y dy. And so I'll say negative du is equal to sine y dy. And we have a really, really nice u substitution. We wind up having negative, right? Yeah, okay. Negative 1 over u du. And so I can say that my integral there is, oh shoot, if I don't include this work, there, okay. Sorry. So the integral of 1 over u is the natural log of the absolute value of u. So there was a negative on it, so there's still a negative on it. And so we got tan x plus c over here, and then so we dropped the u back in. U was cosine y. So negative ln cosine y is equal to tan x plus c. Okay, so we absolutely can solve this for y. So I'm gonna, and it's gonna be painful. This really would be a fine place to stop on a question like this a lot of times. And I didn't really give any indicator that you, let's see, did I say solve for y? Leave in general form, don't find c. So if you're kind of following my guides, you'll notice some of the guides earlier. Wasn't there one where they didn't solve for y? Oh, I must be misremembering. Yeah, it looks like we're solving for y in all these. So, yeah, no. There was an example where we had something that was so complicated that solving for y didn't really make sense. So, let's talk about solving this for y. So I'm going to divide both sides by -1. I'm going to get the natural log of the absolute value of cosine of y is equal to, I'm going to say c minus tan x. That might sound weird at first, but if you think about it, we're dividing that by -1, then we're dividing this by -1, so it turns into negative tangent, and we're dividing a c by -1. C could be positive, c could be negative. So this is one of the situations where I could call this first one c1, and now I've got a c2. And this c2 may in fact wind up being negative, but it doesn't matter. So if you don't like that, just keep it as negative c, that's fine. So now to get rid of this, I'm going to e both sides. I'm going to get cosine y is equal to e to the c negative tangent x. Let me think about that. So I could write that's e to the c times e to the negative tangent x. So I could write that as capital C e to the negative tan x, or capital C over e to the tan x, since it's a negative exponent. So if I do that, then I can say y is equal to the arc cosine of c over e to the tan x, right? Because to get rid of cosine, we can do arc cosine or inverse cosine. So I think I'm going to go fine and ew. Okay. Let's look at our next one. We're getting near the end of these. We should expect kind of some messier things. I love how at the beginning of the last one I was like, oh, a nicer one. Yeah. Oh, shoot. Well, this is the last day before break, so hopefully I'll be able to catch you guys on this. I am anticipating some issues on this one. I see cosine 2x sine 3y. That's telling me maybe I'm going to need to use double angle or stuff like that. Oh, wait. No, overthinking it. I'm way overthinking this. Okay. So if I separate my variables out, I get sine 3y is equal to cosine 2x dx integrate. No, dy. Integrate. All right. So let's set the u in this one equal to 3y. So du is equal to 3 dy. So basically, it's just going to be 1/3 sine u du. And if you can kind of see that logic, this one's going to follow the same thing. We're going to have 1/2 integral cosine u du. U in this one is 2x, so du is equal to 2 dx. So I'll solve this one differently. I mean, I didn't solve that at all, did I? I just manipulated it. So I'll solve this for dx and get du over 2 is equal to dx. Okay. So I got home from school yesterday, and my voice was all the way down here because I'm not feeling well. My wife was like, "Well, your voice is so deep," and I was like, "I know." And then I took NyQuil and slept all night. All right. let's see, so sine u, let's see, the integral of that is negative cosine, so negative 1/3 cosine u, and then the integral of cosine is sine, so 1/2 sine u plus c. Remember, the plus c could go on both sides, but we're just putting it on one side. You're so repetitive. Yeah, I know. I'm slow to learn, so I figured some of my students are. Now, this is like, it's really bad that we've got a u over here and a u over here. Like, maybe I should have used different letters, but like, can't be bothered right now. This u was 3y. This u was 2x. If I really want to solve this for cosine, for y, I absolutely can. So I'm going to circle this here and go like, good. Now I'll solve it. So I'll multiply both sides by -3. Cosine 3y is equal to -3/2 sine 2x plus c. Remember, I'm multiplying the c by the -3, but it's a constant multiplied by a constant. It's just a new constant. So I will call this C1. So that's going to be a C2. It's a different number. Then I'll do arc cosine both sides. And I'll get 3y is equal to arc cosine of -3/2 sine 2x plus C2. And then we'll finish it off. Did I open them close? All right. Well, where'd my orange marker go? Is it orange or orange? Or orange? And someone goes, no, that's red. Okay. And we'll call this an ew again. Maybe I should say good enough. Good enough. All right. It's the last of the general. Now let's get into the specific. So, number 9. Divide dx is equal to x squared minus 2x minus 4. F of 3 is equal to 6. All right. Sorry about that. See, f of 3 is -6. Okay. So let's go through and pop this out. This one's actually pretty simple. You could even just you don't even need to bring the dx over here if you understand kind of what's happening. So put the dx over there and integrate. You get y is equal to x cubed over 3 minus x squared minus 4x plus c. We just got to find use our initial condition to find the constant of integration. So we know the y value is -6. We know the x value is 3. So that's 3 cubed over 3. That's going to be 9. Now this is dangerous. Canfield, slow yourself down. 27 over 3 minus 3 squared minus 4 times 3 plus c. It's even writing 27 there is dangerous. I should just show that the 3 is getting plugged in and then start skipping steps. Let's see, -6, 27 over 3 is 9, minus 9, oh cool, they cancel, minus 12 plus c, so I'll add the 12 to both sides and get that c is equal to 6. So, final answer is that y is equal to x cubed over 3 minus x squared minus 4x plus 6. All right. 10. Oh, goodness gracious. 10 looks so bad. I am going to go home and cry for at 5, maybe 6 hours about number 10. All right, truth about number 10. I looked at it at first, and I was like, oh no, wait, I bet it's easy. Let's see, y of 0 is equal to 1. So, remember, we got to separate our variables, right? So divide both sides by y, multiply both sides by dx. If I do that, I get 1 plus y squared over y dy is equal to e to the x dx. Well, the right-hand side's like a baby equation. It's e to the x plus c. Oh, wow, that was the hardest integral ever. Left-hand side, well, we're dividing both by y, right? Well, so why don't we just break it up and say 1 over y plus y squared over y. Wait, that's 1 over y plus y dy. You might remember this from the notes on this. So integral of 1 over y is just natural log of absolute value of y, and then that's y squared over 2. That was not that hard. So this is one of those ones where I am not going to be able to explicitly solve this for y. I do not have an algebraic technique to get a natural log and a non-natural log together to handle it. If you have one, I would love to see it. And that's not like a challenge, specifically, Nick, that's not a challenge. I'm not trying to get you to, actually, you're probably not watching this video, are you? Mulek, not Alan. I'm an embarrassment to my family. Anyway, y of 0 is equal to 1, so I plug in 0 for x, I get 1 for y. So that's natural log of 1 plus 1 squared over 2 is equal to e to the 0 plus c. Turns out really nice because natural log of 1 is 0, that's a half. This is 1 plus c, so we'll subtract the 1 from both sides and get c is equal to negative 1/2. So if we get c is negative 1/2, then we can say the natural log of y plus y squared over 2 is equal to e to the x minus 1/2. I do feel the need to remind you guys at this point, I've been writing it y squared over 2 because when you've been doing this long enough, you get really comfortable with that. If you would prefer to write this as 1/2 y squared, remember that you're exactly right. Now, when I say exactly right, I mean assuming I didn't make any dumb mistakes in this problem. But that idea of y squared over 2 versus 1/2 y squared, the same idea, there's no error in writing it either way. Okay, number 11. Oh, thank heaven. What? I'm scared. I'm scared because 11 looks like it's easier than number 10, and I feel like that's wrong. Y of 2 is equal to 10. I'm like, what curveball am I missing here? Well, let's see. So we'll separate the variables out. We'll take the derivative. The integral will get y is equal to 6x cubed over 3 plus 4x squared over 2 plus c. Okay. Nothing. We get y is equal to, so I'm going to simplify this, 2x cubed plus 2x squared plus c. So when I plug in 2, I get 10. So that's the way I really should be doing these. I should be careful, do that, now start speeding myself up if I want. So that's plus 8. That's 8, that's 16. 10 is still over there. I got negative 14? Yeah. Okay, so I don't know what I'm missing. This feels wrong. That's not the right, this feels so wrong. No, there's nothing inappropriate here. It's just really, that last question was so much harder than this one. All right, 12. Okay, now we're getting into the weird ones. This might be the strangest one yet. I don't even know if there's one in the notes that's quite like this. But I had the notes last week, so. Anyway, I need to separate the variables out. First thing is dy dx is not by itself, so I've got x and y here. I'm gonna add the x, y to both sides. So dy dx is equal to xy plus x. And still, you might have trouble separating the variables at this point because it's not pre-factored for us. If we were to factor out an x here, now it should become more apparent. We can divide both sides by the y plus 1, leave the x over there. So we get the 1 over y plus 1 dy is equal to x dx. So now, when we integrate that, I don't want to assume you guys are comfortable with this, so Just going to remind you that if we said u was equal to y plus 1, then du is equal to, because I don't know that antiderivative, dy. So I can do a pretty perfect u substitution, and this is just 1 over u du. And this, we can take this integral and get x squared plus c over 2, x squared over 2 plus c. So with this, well, the derivative, the integral of 1 over u is the natural log of the absolute value of u. So since there wasn't any chain rule that happened here, since the derivative of y is just going to be a 1, that's why this turns out to just be that. Sometimes we get things messy, it's messier, so that's why I wanted to be careful and spell that out. So it's the natural log of y plus 1 is equal to x squared over 2 plus c. So, and then y of 0, oh, thank you, is equal to 3. Wait, that's terrible. Y of 0 is 3, so I plug in 0 for x, I get c by itself over here, and then I get the natural log of 4. Oh, I don't need absolute values, it's a positive. So c is ln of 4. So we get ln of, let's keep moving. So we get ln of y plus 1 is equal to x squared over 2 plus the natural log of 4. All right, I'm going to be bold, and I'm going to actually solve this for y, because this has a nice ish looking thing when we solve it for y. So let's go for it. So the first thing we're going to do to solve this for y is we're going to e it. Let me just write it one more time above it to show that, like, hey, this is what we got. All right. Hoping ln 4 is right? We plugged in 0 for x, got 3 for y. Okay, cool. So on the left-hand side, now we have y plus 1. On the right-hand side, we have e to the x squared over 2 times e to the natural log of 4. Hey, wait, e to the natural log of 4, what's that? It's 4. So if you watch the notes video, you might remember from that e to the ln, they cancel. All we're left with is that number. So final answer, y is equal to 4 e to the x squared over 2 minus 1. And I wish I could go back in time in the video and be like, hey, you might have done this slightly differently. So some people, a lot of people, what they'll do is at this stage, here, at this stage, they'll e both sides there, and they'll say c e to the x squared over 2 is equal to y plus 1. Like, it's a really common way to do that, and I did that in the notes. For me, it's, if I remember to do it, I'll do it, because it definitely is a little bit slicker and goes a little faster. All right, that was number 12. Only the long ones left, right? 2 more. Consider that, oh, I can probably just do this one. No, do it on paper. 13, not numbered. Not numbered 1. Okay. Consider the differential equation, dy dx is equal to x squared y minus 1. Find the particular solution to given, wait, why is this in here? That's all we were doing on the previous page. This, maybe just to show you the wording. We're just showing you the wording. So, like, really, it's a normal equation, normal question. So we've got our 1 over y minus 1 is equal to dy is equal to x squared dx. So I just divided both sides by the y minus 1. This integral on the left-hand side, when we take it, is going to work very similarly to what it did last time. You might even go, it's the same question. I assure you, it's totally different. This says y minus 1, this is y plus 1. That was x, this is x squared. It's totally different. This said f of 0 is equal to 3. This says y of 0. It's like the same question. Yeah, okay. So I'll do this one the other way, the more elegant way. So we get the natural log of the absolute value of y minus 1 is equal to x cubed over 3 plus c. And now before I plug in my initial condition, I'll e both sides and get y minus 1 is equal to c e to the x cubed over 3. This is the general, the leap that they'll take. Now, if you're struggling to get from here to this step here, go look at the previous question. Go look at number 12. And that should spell it out clearly how we got from here to here. If this wasn't just a plain y, if this was like 1 minus y, then there'd be more I have to do, and I definitely would want to handle a u substitution, or at least think critically about it before we move on. Over on this side, similar. If there was more stuff going on, we'd want to be a little bit more careful. If you're not sure how I jumped from this to the c, again, it's all spelled out on the previous page. And I did it a couple minutes ago. So now I add the 1 to both sides and get y is equal to c e to the x cubed over 3 plus 1. All right, plug in 0 for x and get 3 for y. So 3 is equal to c e to the 0 plus 1. 3 is equal to c plus 1. Because e to the 0 is 1, so c is equal to 2. Final answer, y is equal to 2 e to the x cubed over 3 plus 1. So hooray. Actually really like that question. Previous one too. They're really good. Let's see. Yeah, final question. Final round. The function f is differentiable. It says differential, but it should say differentiable for all real numbers. X, it should say x. The point 3, 1, 4, so we got 3, 4, is on the graph of y equals f of x, and the slope at each point is given by dy dx is equal to y squared times 6 minus 5. Okay. So A says, so dy dx is equal to y squared 6 minus 2x. First question says find d2y over dx squared, and then 3 1/4. Okay, we can do that. So to find d2y dx squared, we just gotta take the derivative of the derivative that we have there. So let's say d2y over dx squared is equal to, gotta do a product rule, right? So I'll take the derivative of the first, which is 2y prime. Leave the second alone, plus the derivative of the second, which is negative 2. Leave the first alone. And it says find the second derivative, and then it says evaluate it at the point. So this is not the second derivative in a form that we're allowed to leave it. We can't have the second derivative referencing the first derivative. I need to replace this y prime here with that. So I am gonna have to squeeze this in a little bit. So I'm gonna say 2y squared times 6 minus 2x. That's that. Then we got our 6 minus 2x. Then we got our minus 2y squared. Okay. So I'm going to clean this up a little bit because I don't feel like dealing with it. So the 2y squared, I could write that as 2y cubed, and then I could write this 6 minus 2x. Since there are two of them, I could put the squared on that. Minus 2y squared. And yeah, we could do more algebra, write more things, but I'm lazy. I'm going to write y double prime over here. It's the same thing, right? And we're going to evaluate it now at that point, at 3 1/4. So let's do that. So when x is 3, y is 1/4. Oh, that's sneaky, sneaky. So let's see, 2 times a fourth cubed. Let's see, a fourth cubed is, hold on, 6 minus 6 is 0. It means I don't care what that is. Sure, 2 over 64. Woo, so 1/32, or just 0. I don't care what that is because times 0. And then 1 over 4 squared is 1/16. So 2 over 16, which is 1/8. So I got 1/8. So I got this. Then I got this. Need both. Needs both, per the wording of the question. All right, part B is very different. So this was number 14, which is not number 2. So here's 14b. dy dx is equal to y squared 6 minus x. All right, so let's separate the variables out and go through the problem. So not really any more difficult. We got our 1 over y squared dy is equal to 6 minus 2x dx. And just bop through it. So we got careful Canfield. People probably are going to get messed up on this. So this is y to the negative 2 dy. That means that this is going to be add 1 to the exponent, y to the negative 1, then divide by the new exponent. Just be careful with that. Then this one's going to be, let's see, 6x minus x squared plus c. Then we know that when x is 3, y is 1/4. And if I'm careful about that, a fourth to the negative 1 is 4. So this is actually negative 4. That's 18 minus 9 plus c. This is just nice. We get negative 13, right? Yeah, add the 9, you get 5. Subtract the 18, you get negative 13. Okay. Find y equals f of x by solving the differential equation. Blah. Okay, so we get y is equal to, and saying y equals f of x is telling us you have to solve it for y. You can't leave it part way. All right. Let's see this. Oh, wait. Don't do what I did. All right, I got to start here, right? Negative y to the negative 1 is equal to 6x minus x squared minus 13. Divide both sides by negative 1. Y to the negative 1 is equal to negative 6x plus x squared plus 13. To get rid of this, I could take both sides to the negative first power and get y is equal to 1 over negative 6x plus x squared plus 13. So, just a reminder that if it's to an exponent, so that's definitely one way to do it. An alternate way to handle that, we have y to the negative 1 is equal to negative 6x plus x squared plus 13. Okay, so just an alternate algebraic route to the same answer. Well, remember that y to the negative 1 is 1 over y. So then if I multiply both sides by y, I get that times y, and then to get y by itself, I'll divide both sides by that. So that is a 4-step version of the 1-step version that I did before. So I hope these videos have been helpful going through the notes and homework assignment accompanying our spring break assignment. I hope it didn't take too much of your time. Actually, I mean, if you follow the videos, tops, it's a couple hours, and I really just want you guys to be prepared for this AP exam. So, yeah. See you soon.